And I am back with video 3.8, the centroid. I don't know how you all survived the 4-day weekend without a wonderful video from yours truly, but we're going to talk about the fourth point of concurrency today, and that's the centroid. We've gone over the other 3 points of concurrency. If you make 3 angle bisectors from a triangle, they intersect at 1 point. That's a point of concurrency. The same for 3 perpendicular bisectors or 3 altitudes. They all intersect at 1 point. And we've covered those. I'm going to highlight it. We've covered angle bisectors, we've covered perpendicular bisectors, and we've covered altitudes. Now what I want you to do is to write that. Angle bisectors, below that, perpendicular bisectors, below that, altitudes. And I want you to pause this video and write what you think the point of concurrency in those are. The point of intersection of 3 angle bisectors, name that. The point of intersection of 3 perpendicular bisectors, name that. And the point of 3 altitudes, name that. So pause the video and hurry up, because I'm pretty sure Taylor Swift concert tickets are going on sale soon. And if you make me miss the Taylor Swift tickets, I'm going to assign quizzes every single day. So pause the video, write those down. And those are what they are. 3 angle bisectors are in-center, 3 perpendicular bisectors are circumcenter, and 3 altitudes are orthocenter. And the last one is 3 medians, and that's going to be centroid. So if you want to go ahead and write that, 3 medians is the centroid. And those are our big 4. Okay, those are our big 4. The Miami Heat had a big 3. These are our big 4. So what we're going to do is see if the medians are concurrent. And we're not really seeing because I just told you, but we're going to show that they are concurrent, and make sure you know how to construct those, because you will have to do that on your project. So what I want you to do is draw a large scalene triangle. I'll give you a second to do that. Okay, you should have a large scalene triangle, and we need to construct a median. And remember, when you construct a median, what you're doing is a perpendicular bisector of one side, and then finding the point on that side and connecting it to the opposite vertice. So follow along. I'm only going to show you with the compass once, and then I'm just going to do it paused, and it is all going to appear on the screen. So what you do to find a perpendicular bisector, if you remember, is you go over halfway. I'm picking the side that the compass is on right now. You go over halfway, and then you make an arc. And then you go to the other side, the other angle on that side, and you make another arc. Now we're ready to have our perpendicular bisector. And what you do is you connect the 2 points. And you don't need to draw this line. I am to show you how you do this, but you don't need to draw the line. You just need to mark the point that the perpendicular bisector intersects the side of the triangle that you're bisecting. You just need to mark that point. So to show you what I mean, I'm going to delete the actual perpendicular bisector because you don't need it. Then, this is what you do need to connect. You connect the point that you just made that bisects that side, and you connect it to the opposite vertice. And that is your median. So I want you to take time to do to all 3 sides, the median of all 3 sides. And there you have it. Again, I didn't want to take too much time showing you how to do each side. You just do the perpendicular bisector of each side. You get a point, and you connect that point to the opposite vertex. You do that to all 3 sides, and they will intersect at this middle point. And the 3 medians of a triangle are concurrent. So I want you to write that, please. That is the median concurrency conjecture. 5 times fast. That's not the hardest one, but median concurrency conjecture. See if you can say that 5 times fast. Write that down and move on. And now what we have is a centroid, the point of concurrency formed by the 3 medians. I want you to write that as well. The centroid is the point of concurrency formed by the 3 medians. And here we have this triangle. You can just use your own triangle, but this RCN triangle, this RCN triangle, is the one I'm going to show you with. And what we're showing is if we have the three medians and they are concurrent, what we're going to see is something happens there. And you can use your compass or you can use your ruler to do the measurements I'm going to do. I'm going to start off by measuring TD. You can see the compass on the screen. I'm measuring from point T to point D. Okay? Then I go to point D. I stay on that same line and make a little mark. And I go to that mark and I make this mark, and I see that CD is 2 times dt. What's happening is the longest side of a line in the median is twice the length of the shortest side. And you can use your ruler to measure it if you get your medians and they're accurate. And you measure from ED, and I go to D, and I make a mark. I go to that mark, and I see RD equals 2 times DE. It is 2 times the length of the small side. So what you have is from the centroid to the side, that's dt from the centroid to the side, is half the size of from the centroid to the vertex. And this is true on every line. From the centroid D to the side, which is point E, is half the length of from D to R. And that's true of all your sides. And you can use your ruler or a compass to show that that is true. So let's do that with a bigger screen. Let's actually solve the problem. If you look up here in the right hand, on the top left, what I'm highlighting, there's questions that they're asking you. And what did we just find? We just saw that if we go from D to E, and that's going to be half the size of from D to R. Okay? So if we know DE is 5, then what is RD? If DE is 5, what is DR or RD? And I want you to take a second, pause the video, and try to figure these 3 problems out. So please pause the video and try to figure these 3 out. Okay, if DE is 5, then RD is 2 times whatever DE is, which is 2 times 5, which is 10. Again, if you haven't done the second one, please pause the video and try the second one. But if DN equals 14, and they want to know what OD is, so you have D to N is 14. Now that looks like the longer side, which means OD is going to be 1/2 of the longer side, which is 7. The last one is a little bit trickier. It's saying CT, that's the whole length, is 17. From C all the way to T is 17, and they want to know what CD is. Okay? Well, one thing we know is that from D to T is 1/3 of the whole thing, and from C to D is 2/3. Think about this. If CD is twice the length of D, you have 2/3 of the whole for the big part and 1/3 of the whole for the small part. So you could solve CT, the CT problem, which is 18. You could solve for CD 2 different ways. CD either equals 2/3 of 18, and that's the way I would probably do it, and that equals 12. Or you could solve for dt first. You could say dt equals 1/3 of 18, which equals 6. And then CD equals 2 times dt, which is 12. Either way, you get 12. You can solve it either way. If you don't understand what I was saying, please go back over the video and re-watch this part again. This is an important piece of information. So now we have the centroid conjecture. And I want you to write this down, please. And the centroid conjecture says the centroid of a triangle divides each median into 2 parts. So the distance from the centroid to the vertex is twice the distance from the centroid to the midpoint of the opposite side. That's 2 times the distance. So I want you to get that down. Pause the video if you need to. And that is the end of today's notes. I hope you understand everything. I hope you enjoy your weekend, and I will see you on Monday.